Okay, this week I want to walk through some examples on page 287 of your textbook, chapter 10. This covers net present value, profitability index, internal rate of return, and equivalent annual annuity, something that we'll use later for equivalent annual cost for your paper in the class. But first, I want to point out we have two projects here, Project A and Project B, each requiring an opportunity cost of 10%. In previous chapter 9, you will read about the weighted average cost of capital, where it is composed of the after-tax cost of debt. The weighted average cost of capital also includes a component of the opportunity cost for stock. The after cost of debt is for the debt component. The equity component is what we'll use as the CAPM model. But now we have a kind of idea what the opportunity cost is in each project. I have two projects I compare. First, I'm looking at the net present value. Now, with Excel, for net present value, pull up the f of x. The rate I've highlighted as the 10%, and the values represent at the end of each year. So let me just go back and change the rate here and put it back in as the 10%. But I'm just showing that says, all right, for this particular project, we have 500, 500, and 500. And if I use the net present value function, I've just done the actual cells and highlighted, but you could also type in the $500 all the way down. If I hit OK, it says 1243.43, but I have to net out the initial cost. In that case, it was the $1,000. So the net comes from the difference between the present value of the cash flows and the difference between the initial outlay. So that's where I get 243.43. Do the same thing over here for net present value. If I pull that up and highlight the f of x, I can see opportunity cost rate, the different cash flows for the period of 6 years. And if I ever need to scroll down, I just need to get to more or hit tab to get to additional values. But again, net out the initial cost. When making a comparison net present value, the project B has a higher net present value. As long as the projects have a positive net present value, we accept the project. But if you had to make a decision exclusively on the two projects, just standing alone on net present value, you choose project B. Profitability index, if we look at this, I take in this case, the initial cost, the difference between the initial cost and the net present value. So I'm saying right here equals A11. Here was the present value of the cash flows divided by the initial cost of 1,000. Give me 1.243. Same thing was done over here. Got 1.307. As long as the profitability index is greater than 1, we'd accept the project. In this case, again, project B, if it's mutually exclusive, we choose this project. All right, internal rate of return. One big thing I want to point out between internal rate of return and net present value, that net present value, when we do the calculation, like we did up here, we do not include the initial cash outlay. With internal rate of return, we pull this up, the f of x. It will ask for values of a range. We said A4 to A7. So notice with internal rate of return, you do include the negative cash flow. By definition, internal rate of return sets the net present value equal to 0. So kind of just up, if we were up here, if I kept playing around with this rate, if I set this rate to 23.375, that would cause this net present value to go exactly to 0. So looking at these two comparisons, it would say project A has the higher internal rate of return, but that's something we have to be careful with because bottom line cash is king. And you really want to choose the project with the higher net present value. That would actually be the project B, but we could make a mistake though by choosing internal rate of return. Perhaps take a project that gives a manager a better look on paper from a rate of return, but bottom line, the project B adds more cash to the firm. Last thing, equivalent annual annuity. This is based on an example where we invest in something that gives us cash flows back over the year. Know that you could also do this, that if these were changed to cost, if these were negative values, if I'm looking at two machines, this machine costs 1,000, this machine costs 1,000. Perhaps, if examples would be maybe a hot water heater that lasts for 3 years versus 6 years, maybe the one with last for 6 years has lower cost. But for this example, to explain the equivalent annual annuity, what we did is we took, let me pull this up here, the f of x. It says the rate is the opportunity cost, that's 0.1, the number of periods, 3 years, and the present value A13. We look at A13, that was the net present value. So we're converting the net present value into a payment. If we look at that, based on equivalent annual annuity, if I'm thinking about, do I have one project that lasts for 3 years or project B that lasts for 6 years? It's kind of like saying I have to replace this, every 3 years. Okay. Well, based on equivalent annual annuity, and if we kind of look at our example on page 288, it matches up to our calculator solution. It says, well, how do we interpret the EAA? Well, for a project with in-life year, it tells us that the dollar value of an in-year annual annuity that would provide us the same NPV as the project. Thus, for project A, it means that a 3-year annuity of $97.89 with a discount rate of 10% would produce a net present value of the same project A's net present value, which is $243.43. So we've taken the net present value and converted it into a payment. So if we had to make a choice between the two, we'd say, would I rather have $97.89 a year or $70.39 a year? And bottom line, I'd rather have equivalent of $97.89 a year. So the idea would be, we'd convert this and repeat the project again, project A, after 3 years. So that is our examples with net present value, profitability index, and internal rate of return and equivalent annual annuity. Again, we'll revisit this equivalent annual annuity when we look at it from an equivalent annual cost, and I'll give you another video for that to help you with your paper. Otherwise, that wraps it up, but read slowly on Chapter 9, weighted average cost of capital, and do send me any emails if you have any questions with that, but just take your time with that to understand how we come up with these rates of return. And that is it.